Okay, so let's go ahead and get started here. The problem says to find the Fourier transform P1 of f of a pulse given by this function right here, P1 of t. And so we have two functions over here, right? We have function sine and pi. Okay, so let's go to page 202 on the FE handbook. We have the Fourier transform pairs, the table right there, and this is what we have for pi over 2. So basically we're gonna use Fourier transform and then use convolution to solve this problem. Okay, so this is what we have in the tables for function pi over tau will give you in the f domain tau sinc function tau f, and then for sine it's pretty long. I don't know if I will have space to write it here, but yeah, let's just do it here. Okay, so we have sine of, in the time domain, 2 pi f0 t plus theta. This is equal to 1 over 2j e to the power j theta I'm just copying here. Okay, that's the delta function, f minus f0 minus e minus j theta delta f plus f0, and close the bracket. That's okay, so that's for this function right here. Okay, so now let's use the transform for this one over here first, pi t over 2. Now here for that comparing it with this over here, we can clearly see that tau is 1 over 2. Okay, so we're gonna well, tau is basically 2 is what I'm saying, right? Because we have 1/2 times t, so tau is equal to 2, so that should give me 2 sinc function of 2f. Okay, and for sine for this one over here, I'll have sine of, now we have 2 pi f0 times t, and we have 8 pi times t. So if we take out a 2 pi, then our f0 would be 4, right? So this is how it's written. So we have 2 pi 4, which will give me 8 pi, and then I have my t, so clearly f0 is 4, so this is equal to 1/2, right, j. Now we don't have a shift at all. I mean, we don't have a theta here. There's no phase shift at all, so theta is equal to 0, and e to the power 0 is going to be 1, so that goes away, and so we have the delta function only, f minus f0 is 4 here, right, minus f plus f plus 4. Let me put 4, not 0. Plus 4. Okay, that's it. So now if we use convolution here, remember on page 202, at the bottom with the convolution integral, we're not using that one, but it says that when you're convoluting, because this is a delta function, right, and we're trying to convolute that with this the pi function over here. Now anything that you convoluting with the delta function will give you that function, and then with a shift. This translates to xt. Convoluting it with a delta function with a shift t minus t0, this is equal to x with a shift, right? T minus t0. So this is my delta function, and this is my x function right here. So if we use convolution here, this is what I have. So I'm using I'm convoluting these two over here. Let me use a different color. Let's use yellow. So I'm convoluting these two, right? And this is a delta function with a shift. So it stays that with a shift. Okay, so this is what I have. One over let me use a different color as to not confuse it. It's kind of disorganized a little bit, but okay, let's use yellow. Okay, so I will have the final answer for P1 of f. This yellow is crazy. Okay, so P1 of f is now therefore equal to 1 over 2j. I don't like this yellow. Let me use purple. Okay. P1 of f is equal to 1, 2j. Okay. Now the delta function, remember, right, over here, sinc, so I would have 2 sinc two. Oh, let's do this. F. So whatever the shift is, we're just carrying it, right? So I have my 2, but then the bracket, the function itself will be shifted by the delta function, whatever it is in the delta function. So I have naturally f minus 4 here. Okay, minus sinc 2f plus 4, and that's it. That's my that's the final answer here. Let me kind of regroup this. So P1 of f, cancel this out. Now this will give me it will just give me j, and I have canceling the 2's. Finally, I have j sinc 2f minus f minus 4 minus sinc 2f plus 4. And that's it. So you see how the convolution works. I mean, it's just a property that we used here with the delta function, basically. So what we did was we found using the table on page 202 on the FE handbook, we used the table to find the transform of a pi function, pi t over 2, which is this over here. We use the transform table as well to find the transform of sine 8 pi over t, which is over here, and then we use convolution to basically find the final function over here. So this is a convolution property for a delta function, and we just applied it here, and that's pretty much it. So pretty straightforward over here, right? Okay, thanks.